Hi all, my name is Ravi Prakash and welcome to 6th class of geometry. Okay, so we'll continue with the 5th class. We were doing right angle triangle, all those Pythagorean triplets and all, right? We did. Now few questions we'll do. Okay, so see, there's a triangle here. Sides are given as 15, 20 and 25. AD is the perpendicular on the side 25. So we need to find the sum of inradius of triangles ABD and triangle ADC. Okay, let's solve it, right? Now see, again sides of triangle are 15, 20 and 25, right? So once you take the common factor out, that is 5, so it becomes a 3, 4, 5 triangle, 3, 4, 5 triangle, right? That means it is a right angle triangle. So it is a right angle triangle. So in right angle triangle 25, right, longest side is the hypotenuse. So 25 should be the hypotenuse, right? This should be 90 degree. This should be 90 degree, right? Because angle opposite to hypotenuse is what? 90 degree. Fine. This is 90 degree. So now, so for this triangle, right, to get the inradius for triangle ABD, so for this I need to get this inradius, right? Inradius. For this, I need to have the all three sides. Why? Because what is inradius? Semi-perimeter minus hypotenuse, right? You calculate by either way, area equal to R into S, or by inradius is what? Semi-perimeter minus hypotenuse. In both the cases, I need semi-perimeter. Semi-perimeter means what? All three sides I need, right? All three sides I need. So I already 115 is known. So I should I should calculate AD here. So I should first calculate AD. Okay, sorry. I should first calculate AD here. Okay. So now what is AD here? So AD is the height of the triangle, and height can be easily calculated by a very good concept, because area, since it's a right angle triangle, so area is the, what is the area of triangle? Half into 15 into 20. So area of triangle is what? 150. So I can equate area of triangle as 150 to half into height into base. Half into height into base, right? That is half into height into 25. Therefore, height is equal to, solve it, you'll get height as 12. Therefore, AD is equal to 12. So I'll get AD is equal to 12. Height is 12 here, right? So in any triangle, right, is a good concept actually. In any triangle, if all three sides are known, so if all three sides are known, then you can get the area of triangle also. Area of triangle also, and then you can get the height of triangle also, right? If all three sides are known, then you can get the area of triangle as well as height of the triangle you can get. Fine. Okay. So AD equal to 12 I got here. So this is 15, this is 12. So by Pythagoras theorem, BD will be what? 9. BD will be 9, right? What is BD? So BD will be equal to 215 square minus 12 square by Pythagoras theorem. So root 81. So root 81 is what? 9. So BD will be equal to 9. Okay. So this is this will be equal to what? 16, because whole is 25, right? So you have two triangles now. One triangle is, this triangle is 9, 12, 15, and this triangle is 12, 16, 20. And I need to find the inradius of both these triangles, right? What is the inradius of both these triangles, right? Now I can do it directly also. What is inradius? Semi-perimeter minus hypotenuse, right? So inradius is what? Semi-perimeter minus hypotenuse. What is semi-perimeter here? 9 plus 12 plus 15, that is 36 by 2, 18. 18 minus 15, that is 3. So R1 is what? 3. Okay, let's call it R1. Now for second one, inradius I need to find. Let it be called R2 in radius. What is R2 again? Semi-perimeter minus hypotenuse. What is semi-perimeter here? 12, 16, 20 triangle. So 12, 16, 20 triangle. So 12 plus 16, 28 plus 20, 48. 48 by 2, 24 is semi-perimeter minus hypotenuse 20. So 24 minus 20, it becomes 4. Therefore, I need to find R1 plus R2, that is 3 plus 4. What is the answer? Answer is 7. So 7 is the answer for this question, right? 7 is the answer for this question. Okay, now next question we'll do. Okay, so the next question is there's a rectangle ABCD with sides be given 9 and 12. Find the distance between the incenters of triangle ADC and triangle ABC. Okay, just read this question, pause this video for 5 minutes and solve it. Try this question. Okay, we'll solve now. See, now it is find the distance between incenters of triangle ADC and triangle ABC, right? Now see, if you have really tried for 5 minutes, then what is the problem you will face is many people will make these two circles coinciding with each other. Okay, many people will make this two circles coinciding with each other. That means, or maybe just externally touching with each other. Right, that's why I tell you to try. When you try, you will know this mistake, what mistake you can make, right? So I need to find distance between incenters, right? Now how I know that these two circles will be apart and they won't be coinciding or they won't be touching each other, right? See, basically it's a normal common sense funda. See, in any square, right, if it is a square, if I draw a diagonal, these are absolutely two equal area as well as by symmetry also. Everything this side is equal. This is equal, right? All are equal only. So any circle I make here, it will be like making here, and if I make here, these two will be touching each other at this point. Okay, but as soon as I move from square to rectangle, right? So what will happen if it is a rectangle now? So this circle will start getting apart from each other, right? This will like this. Logically, if you make diagram like this, because for in circle, you need to touch this circle at 3 points, right? At 3 points in the circle, right? So for touching it, now this circle will keep on going apart. The more is the difference between length and breadth of rectangle, right? So circle will keep on going apart, right? That's a funda here. So that's why they will not touch each other, because it's a rectangle. Now since it is a rectangle, so in rectangle each angle is 90 degree. Each angle is 90 degree, right? So in this case, and opposite sides of rectangle are equal. So this is 9, this is 9, this is 12, this is 12. Okay, fine. Now I need to find the distance between incenter. Let's join this line. Okay, so I need to find this length, call it PQ. Right, now see, this is very important funda actually in whole geometry. This is nothing but this is an application of Pythagoras theorem, right? Now how it is an application of Pythagoras theorem? Because whenever you have to find distance between any 2 points, right? Whenever you need to find distance between any 2 points, like this, right? P and Q, and these two are neither horizontal nor vertical, neither completely horizontal nor completely vertical, right? So if this is not the case, then this is solved by Pythagoras theorem, right? Notice Pythagoras theorem. So if distance between these 2 points I need to find, or the length of the line, I need to find the vertical distance between these two and horizontal distance between these two, right? So I need to find this length and this length. Since this is horizontal, since this is horizontal, this is vertical, so both will make an angle of 90 degree here, right? So this is A, this is B, so this will be what, root under A square plus B square by Pythagoras theorem, right? So very important point this is. So whenever you have to find the length of a line which is neither horizontal nor vertical, right? It is like somewhat tilted. Blindly get the horizontal part, get the vertical part and solve by Pythagoras theorem, right? So here also I need to, from PQ I need to draw a horizontal line and a vertical line, right, to form this angle as 90 degree, right? But many of you can argue here that why this angle is 90 degree, right? Means why it is necessary that it is absolutely passing through here only. Okay, why it can't pass like this? It's a rough diagram, right? It can pass like this also. It can, without touching a circle, right? It can pass like this also. So why not like this, right? So okay, we'll prove it, right? We will prove it why not like this. Okay. See, what is the radius of the circle? So this is 9, this is 12, this is 90 degree. So by Pythagoras theorem, this AC will be 15. Okay. And in just last question, we saw that for a 9, 12, 15 triangle, what is the inner radius? Same perimeter minus hypotenuse. So it comes out to be how much? It is 3. This radius is 3. Okay. So when this radius is 3, this diameter becomes 6. This is 3 plus 3 is 6, right? This hole is 9. This hole is 9. The diameter is 6. Radius is 3. Diameter is 6. This also becomes 3. Right. Similarly, while coming to this side, again, this radius is 3 here. That means you can see this from rectangle, from this base of rectangle CD. From CD, P is also at a distance of 3 units, right? And this point, right? Name this point as, let's say, R. R is also at a distance of 3 units. What is R? This end point of this circle, right? This is also at a distance of 3 units. That means these two are in a straight line. That means if I draw these two lines, this will be absolutely tangent to this circle. Tangent. This will be radius. This will form 90 degree. Okay. So this is a funda here, right? Now, so how to find this length now PQ? So this I know this is the radius. Okay. This is the radius. So this length is how much? This length is 3. This length is 3. How much is this length now? So this whole is 12. So 12 minus this 3, 9, and minus this 3 also, right? Then minus this 3. This is also 3 now, because the radius is 3. Okay. So this radius is 3. This radius is 3. This is also 3. So, and this is also 3. Right. So 12 minus 3 plus 3. That is 6. So it becomes 6. So this is 6. This is 3. So what is PQ? So now PQ is equal to root under 3 square plus 6 square. That is root 45. That is 3 root 5. 3 root 5. Right. So again a very good question. Fine. Okay. Let's move to next problem now. See. Next question. In a right angle triangle, area is given as 80 square units and perimeter is also given as 80 units. 80 units, right? So both are given. So we need to find the length of hypotenuse, right? It may be a tricky question, right? So it's easy question, but it can be a tricky question if you don't use this funda. That in radius of any right angle triangle is what? Semi perimeter minus hypotenuse. Okay. And second one was what? Area is equal to R into S. Okay. Now area equal to R into S. Area is given as 80. R I can calculate here. And S is given as what? What is S? S is semi perimeter. So half of 80 is what? 40. Therefore you get R is equal to 2. So if you get R equal to 2, you can place this R2 here. So R is 2. What is same perimeter? 40. Okay. So what is hypotenuse? So hypotenuse becomes what? 38. So 38 is the answer for this question. Right. So it's a good question. Right. You know this basic funda. That's it. Okay. Next question. The next question is what is the area of the triangle? What is the area of the triangle with circumradius 8? Sorry, not circumradius 8. With circumradius 18. Okay, circumradius 18 and in radius is equal to 8. Here's a question, right? What is the area of triangle with circumradius 18 and in radius 8? Okay, let's solve it now. Now we know that in any right angle triangle, what is circumradius, right? Circumradius is 18 and it is what? It is half of the hypotenuse. So I can get the hypotenuse length is what? So hypotenuse length is what? 36. Okay. So length of hypotenuse is what? 36. Okay. Now if length of hypotenuse is 36 and here if small r is again 8. So again in radius is what? semi-perimeter minus hypotenuse. Now 8 is equal to semi-perimeter minus hypotenuse 36. That means semi-perimeter becomes what? It becomes 44. Therefore, what is the perimeter? Perimeter is what? Perimeter is 88. So perimeter is 88, right? So if perimeter is 88, so what is the area? Therefore, area of any triangle is what? Given as what? R into S. So R is what here? R is 8 and S is 44. So what is the answer? 40 into 8 is 320. 4 into 8, 32. So 320 plus 32, 352. So answer for this question is what? 352. This is the answer. Okay. What is the area of triangle with R equal to 18 and R equal to, that is circumcenter. Capital R is what? Capital R is what? Circumcenter. What is small r? In capital R is not circumcenter. Circumradius. And what is small r? Inradius, right? Okay. Next question we'll do. Write down. In a right angle triangle, A, B, C are its sides, such that C is greater than B is greater than A, right? It is given that 2A plus 7C equal to 9B. This is given. And A is equal to 12. This is also given, right? So find the length of C. Find the value of C. Okay. Now it's a very good question, right? If you don't get the concept, it's a very tough question. It will keep on solving. You spend 5 minutes on it, you will not get the answer, right? You solve the correct way, you will get the answer, right? So you know that ABC are the sides of the triangle, okay? And A is greater than B is greater than C. That means C is the hypotenuse. A is the smallest side, that is 12. This is also given, right? Okay. So now what we can do here is, in this case, we can write like this. See, 2A plus 7C equal to 7B plus 2B. Fine. That means 2 into A minus B is equal to 7 into B minus C. That means A minus B upon B minus C is equal to 7 by 2. Now, very important equation, right? So if A minus B upon B minus C is equal to 7 by 2, then I just need to find this, right? I know that ABC is any triplet. ABC is any triplet, right here. I just need to find that triplet here. In which difference of A and B is 7, right? A minus B is 7 and difference of B and C is 2. This I need to find here, right? So if you observe all those basic triplets which I told you to remember, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, right? 9, 14, 41. Like this, you'll write all the triplet, 20, 21, 29. So you'll see that 8, 15, 17 satisfies it, right? Difference between A and B is 7, that is 8 and 15. 8 and 15, difference is 7, and B and C difference is 2. Satisfied this, right? That means 8, 15. So A, B, C, 8, 15, 17 triplet satisfies. It's a very good question, right? Which talks about the understanding of the triplets, right? If you know the triplets, do it very fast, right? Otherwise, you put the value of A equal to 12, do some hit and trial, go into deep algebra, right? You'll not get the answer. Very difficult, right? Lengthy. So now you know that. Now it is given that A is equal to 12. It is given that A equal to 12, right? So what I can do is, also I can put the value of A 12 here, but simply it is like ABC is 8, 15, 17 triplet, right? Now since A equal to 12, so instead of 8, A is 12, right? That means this triplet is what? This triplet is 1.5 times the original into 1.5. This multiplication, right? Into 1.5. So this triplet is what? 1.5 times the original. Okay. So if 8 is 12, then I need the value of C, right? C is the hypotenuse, because given that A is less than B and B is less than C. So C is the longest side, C is the hypotenuse. So if 8 is 12, that what is 17? Again 1.5 times. So into 1.5, 25.5. That means therefore C becomes 25.5. Right. Very good question. Super question. Okay. So C is what? 25.5. Okay. Now in next videos we'll discuss further concept. Thank you.